Hello everyone, in this tutorial I will show you how to set up machine learning to train the vehicle to drive along the racing track. Machine learning focuses on training algorithms to learn from data and make predictions. This might look complicated, but everyone can follow along with this tutorial. All these vehicles are trying to drive along the racing track without colliding with other vehicles, and it learns from the reward and from the mistake that they make. We will follow along with this tutorial first, and then we modify this project to get the vehicle to have the collision. Go to Epic Game Launcher and I use Unreal Engine 5.3. Choose game and use this vehicle template. The project name is Learning Agent and create. Go to plugin and search for Learning Agent. Learning Agents is a machine learning library for Learning Agents is a machine learning library for AI character control in games. Enable this and restart. We can delete some of this mess, this obstacle. And go to vehicle template, blueprint, sport car, duplicate this sport car, and this one name is sport car player, and this sport car pound is for our agent, and this is for the player control vehicle. Go to world setting and find this vehicle at one game mode. Choose sport car player. Save this and let's play. We have this vehicle that we can drive by press W to move forward and left, D and A for left, turn left. Can hit brake when we press S, backward, or press space for brake. Next, we need to create Learning Agent Manager. Add a new folder. Name is Learning. And create blueprint or class. Search for Learning Agent Manager. Choose this and select. The name is BP OL Training Manager. OL is for reinforcement learning. And we can drag this OL Training Manager inside the scene. You can set it any location. I set it to 0 location. Open the vehicle Sport car pound, and we need to register it as the agent. The agent is the actor that we will train it. You can scroll down and control to zoom out, scroll the middle mouse and select all of this and copy and paste it here. We register the agent with the manager, and this is the agent ID. Let's create variable. And if the learning agent is not valid, it print this tag. Next, we need to add spline, create blueprint actor, BP, port, track spline. Open this, add spline. And drag it to our scene. Drag it here. And adjust this spline. Let's go to top view. And this spline is here. Move it. Set its location to 0. And we can click on the spline and move this. Move it here. And we can select on this and duplicate spline point. Move it to the racing track. Duplicate spline point. We wait until we move it along this track, and then we close this line. Duplicate. Duplicate this point one by one and move along the track. We need to close this spline. Click on this and close loop, enable. Next, we need to adjust this. We can hide this plane. For us, easy to select the spline. You need to have some patience because it will take a lot of time to adjust this point to have the right flying curve. And we finish adjust this spline. Let's go to perspective. Set this mesh to visible. Next, create another blueprint. For class, search for learning agent interactor. Select. The name is BP driving interactor. We need only 3 blueprints. The first is interactor, policy, and trainer. Open this driving interactor. We can close this line track and this sport car pound. Begin play. Get actor of class. Choose BP sport car track spline and get the spline. Remote to variable. Rename to track spline and connect it here. Next, we need to set up observation. Copy this and paste. The observation are track position observation, track direction, track global position, car velocity, flying component helper. And we can promote this to variable. Create variable. And compile. And copy this. And paste here. Set observation. From our agent, we get the location and get distance along spline at position to observe the position of the vehicle and their direction. Copy this. And this is the action that our agent can make. They can hit brake, action, move forward and backward, and they can steer the vehicle left or right. Create variable. and get action. Copy. And this is the value that the agent need to make the decision from. We get from the agent is sport car pound, and this set throttle, set brake, and set steering input. Let's compare, see if there are any error. It's all correct. These are all the observations that our vehicle make. To turn this into action, we need the policy component. Create another blueprint. Search for learning agent and choose learning agent policy. Select. Name is BP driving policy. And we don't need to adjust anything in this policy. And another one is learning agent trainer for training this vehicle. BP driving OL trainer. Open this. And we can copy this. In the begin play, we get the spline. Create variable of this spline. And then set up the reward. We have off-track penalty when the vehicle go off the racing track. Velocity along track reward when the vehicle move along the spline and it gain the speed. So we give the reward to our agent. And this is the spline component reward helper. Copy this. Set reward event. This we use the position of the nearest position on spline and compare it with the actor location. And we check the different position between these 2 points to give the penalty to the vehicle when it's off track. And this one we check the velocity along the spline. And if it gain the velocity, we give the reward for the agent, so it know which is the bad action and which is the good action. And copy this. And we set up the completion of track termination. We terminate the vehicle that go off track. The threshold is 1,200. to prevent the vehicle from learning from the bad behavior. And when it's too off track, we need to reset the position for the vehicle to restart. To reset the position, we need to go to Sport Car Pound. That is our agent. Add function. The function name is reset to random point on spline. Click on this and add input. The name is spline. Variable type is spline component. Object reference. Copy and paste it here. Connect this to spline length. Get location distance along spline. And get rotation at distance along spline. Connect this to set actor transform. We set the actor transform with the random location of the spline when it go off the track. Copy this, reset episode event. Go to driving OL trainer as it. And for agent ID for each loop, we call reset to random point on spline and use this spline track as the spline. And let's compile. Next, we need to go to learning OL training manager to set up all these driving iterator, policy, and trainer together. Go to event graph. And we can scroll down. In the begin play, let's copy this. In the begin play, we need to set up the iterator and the policy setting, the variable, driving OL trainer and trainer setting. Let's compile this. See this policy setting. We have this setting. We don't need to change it. And the trainer setting. And in event tick, copy this. Create variable, trainer game setting, trainer path setting, critic setting. and we reinitialize policy network because it is the first time that we train the neural network. Save all. And then we go to this data set and choose learning agent neural network and select. Rename it to DA dataset driving network. Set this to this neural network asset. When the vehicle learns, it will create the pattern in this neural network, and it use this neural network to predict the action that this vehicle should take to get the best reward. Go to this class default. Set the tick interval to 0.1 second. And this make agent number is 32 because we want to have multiple agents so we can train and get the result faster. Next, we drag our agent, this Ford car pound, into the scene and duplicate to 32. One line we have 4. To get 32, we need 8 lines. Duplicate. Three, 4, 5, 6, 7, and 8. Save this. For this, we want to disable the collision of the vehicle. To make this simple, first search for collision and choose custom and disable this collision of the vehicle. It can overlap other vehicle. Go to editor preference. Search for useless CPU when in background and disable this. Clean this log. Let's clear this and start training. Close all of this. Play. Let's see this log. It is not working. We get a lot of error here. This error happened because I made some mistake here. We need to add BP driving iterator component, BP driving policy, and BP driving all-L trainer. Let's move it here first and connect this. Because in this variable it is empty component. and connect policy. And this trainer. Delete all this class variable and delete this component BP driving iterator, driving policy, or L trainer. Compile and that delete this one to rename it. And compile, save. In sport car pound, the reset to random point on spline function, I forget to set the physics linear velocity. We set this physics linear velocity to 0 because when we start reset, we don't want the actor have the velocity. Compile and save. And to train again, we can go to DA driving network, reset network, and save. Make sure that this reinitialize policy is true when you retrain the network. Then hit play to train. And this is the player vehicle we can drive around. And we can place this outside the track. Press F8 to go outside the vehicle. And you can see this vehicle when it gets out the track, it gets terminated and placed on the spline somewhere to restart. The vehicle gets the reward when it moves along the track correctly. And the higher velocity, the bigger the reward. If it gets outside the track, it gets the penalty. Similar to how humans learn. Example, we learn to walk. When we walk straight without fall down, we get the reward as the dopamine that make us happy and feel we achieve something. If we fall, we hurt ourselves and it is the penalty. So we decide the action that is the best action to get a lot of reward. This is called reinforcement learning. It takes a lot of time to train this. You will see some interesting behavior after 15 to 13 minutes of training. We can check the output log. On iteration 28, the reward is minus 0.04, and iteration 0, the reward is minus 0.13. And iteration 156, the reward is minus 24. So let it train for 30 minutes and we will see the reward if it gets more reward. This is the result after 30 minutes of training. Iteration 4446. we can see some vehicles have fast movement. So this is the good start. After 1.5 hours of training, we get this result. Let's go to output, and the iteration is 13,650 iteration, and the average reward is 0.6. If we continue to train this for longer time, we will get higher average reward. I stop it here because the result is looking good enough for me. Let's stop. And if you want to continue to train, you can go to OL Training Manager and disable this, and then hit play to continue the training. Now let's save the data set, and we get our neural network for this driving. And let's close this. I want to duplicate the project. This learning agent, copy and paste it. We name this to learning agent collision because we will enable the collision. And open this learning agent, the last project. To use this neural network to drive the vehicle, we can duplicate this OL Training Manager, name it to Inference Manager, open, and we delete this setup trainer because we don't want to train it again. Delete this, run training, get BP driving policy, run inference, and even tick, and compile and save. And instead of this OL Training Manager, search for BP, delete this OL Training Manager and replace it by BP Inference Manager. And we want less vehicle than this. Let's delete some of it. Let's rotate this 180 degrees. And rotate this to 180 and move it back. Let's play. And we can see our vehicle can drive, but it don't have the collision. So our training is successful that our vehicle can drive on the track. Next, we will modify this project learning agent collision that we duplicate it to have the collision. Open this. Go to the vehicle. And go to mesh. Search for collision. Set this collision preset to vehicle collision. Compile and save. Our vehicle will move along this direction, so we can rotate this vehicle like all sport car pound and rotate 180 degrees. And this one, player start 180 and move it back of the vehicle. Sport car pound, because we enable the collision, so when we reset it to random point on spline, it can overlap with other vehicle and push other vehicle out of the track. So we don't want to have this situation. We need to spawn a speed trace, see if there is vehicle there. If there isn't, we can set to that location. If it have other vehicle, we need to change other location to reset. Let's add location variable. Variable type is vector. And set this to location variable. Next to location, move it back here. Call peer trace for object. Use the location, start and add location. And the radius is 200. And we make array object type is vehicle. Then if it hit, create a branch. Do one. And loop back to the location to get another location. And connect for to this that actor transform if it isn't any vehicle on that location. Get location, connect to this location. Go to driving interactor, and we need another function to call the line trace. And this line trace acts as the sensor for the vehicle. Add function find hit location. At input, name is actor, and this is actor. Object reference, add local variable, hit positions with the and change it to array. Another one is add position. First, we clear this array. And we get actor location from the actor, break vector, make vector, x to x, y to y, and z, add with 50. I want the location of the line trace to be higher, and add another variable. Name is angles. Just float, and this angle call for each loop. Then get actor rotation, make rotator, split this actor rotation, like yaw, and get forward vector, multiply, add another variable is line trace length. Set this to single, convert this to float, and this vector we rotate vector around axis. Vector up use as the axis. This angle, rotate it around this angle. And this location, we add it. For each loop, line trace by channel. Connect this to start and this to add location. Set it to visible. We can draw the debug for one frame. Draw time. We don't need to change because we draw it for one frame. And actor to ignore. We ignore ourselves. Is the actor, the input actor. I chose the wrong node. Multi-line trace, not multi-line trace. Line trace by channel. Reconnect it. and this one for one frame. Delete this, break the hit result, get hit position, add the array, get add positions, add array, when the line trace don't hit with other vehicle, it will return 0 value. So we don't want to get the 0 value, we want to have the add location as the result if it don't hit anything. Call select vector, return this location if it's true, and if it false, use this add location. Need to add, and this add position, add to this, and when it complete, return, get hit position, and add position, save first, named, return, add position, and return hit position. This line trace length, set it to 1500, and the angle, let's add 5. We want 5 line trace. The first is minus 45, minus 22.5, 0, 22.5, and 45. Compile and save to event graph. And we need to add another observation. Add this pin, add this setup observation. Call add planar position array observation. Name is sensor observation. Number position name is 5, scale 100, and promote this to variable is sensor observation. Set observation. We need to add another pin and call this find hit location for our line trace, and connect this agent to the actor, and call and get sensor observation. Set planar position array observation. And this agent ID, make it here. Make hit position to the positions. The location of the actor. to relative location and rotation. To relative rotation. Compile. Go to BP driving OL trainer. We need to set up backward penalty to prevent our vehicle driving backward. And even set up reward at pin. Call at planar position different penalty. Name is backward speed penalty. Weight is 1 and scale is 1. Threshold set it to 0.1 and promote it to variable. Variable name is backward speed penalty. Even set reward. Let's add another pin. Get backward speed reward. Sorry, backward speed penalty. And call set planar position different penalty. This agent ID. Get velocity and normalize this velocity. We get actor forward vector. Dot product with this forward vector. And we make vector. And connect it to this position. And the position, first position is X is 1. We only compare this X. When we dot product, if it go forward, the result will be 1. If the vehicle go backward, the result of X is -1. If it go backward, it will get the penalty. Next, we will set up the hit termination to reset the vehicle when it hit with other vehicle to prevent the vehicle from learning from the bad behavior. Go to driving interactor. Copy this find hit location function as this function here. Move it down. Add planar position different completion. Name is front collision completion. Threshold is 380 because our line trace will be 700. And set this to termination. Promote to variable. The variable name is front collision termination. Copy this, pass here, and the name is back collision termination. We only check the collision for direct hit from in front and from the back of the vehicle. Promote this to variable. Rename it to back collision termination. Go to find hit location and local variable. This angle, delete all and add. The front is 0 angle and the back is 180 degree. Line trace length is 100. Compile to event graph. And this set completion event. Find hit location. And our agent as the actor. Get front collision termination. Set planar position different completion. And agent. Like this array agent. Add position. Get 0. And get 0. The first index is 0 degree. So it is the front collision. And copy this. Get back collision termination. And array element. Get 1 index of the array. The first index of the array is 180 degree. It is the back. Get so it compares the hit position with the head position of the line trace. If it exceeds 380 the length, the vehicle will reset. This reset event will call and reset to random point on spline. Let's save this. Go to this driving network and reset this network because we want to train it again. Clear this, lock. Go to make sure this is reinitialize policy network because we train this again. And close all of it. Save all. BP and BP or Air Training Manager is in the scene. Is correct. And let's run this. And you can see this line trace. We have 5 line trace. And the front and this one check for the collision at the back. And when it's hit, we can see the green line when it's hit with other vehicle. So let's give it some time for our agent to train itself. Go to output log and iteration 0, the reward is minus 1.39. This is the result after 6,100 iteration. The reward is minus 0.56. And you can see when the vehicle hit with other vehicle from front or from the back, it terminates that vehicle. This training can take a lot longer time than the last one because we enable the collision, so the vehicle need to learn to avoid this collision. After we train this vehicle for nearly 4 hours, we get the vehicle that try not to hit other vehicle and it's move in one direction along with the spline track. It is not yet perfect. You need to continue to train this. And now it is 34,188 iteration. And the average reward is 0.19. And this is the result. Thank you very much for watching. If you like this tutorial, please hit like and please subscribe to my YouTube channel. Thank you very much for my patrons member who are supporting me. Your support really means a lot to me. See you in the next tutorial.